Hello everyone! Today we're going to be looking at logic gates. So the logic gates we're going to have, I'm in the Falstad Circuit Simulator. I have a video on that if you want to check that out. But we're going to actually be using it today. So we're going to have NAND, NOR, AND, OR, and exclusive OR, along with an inverter. So let's start playing with the different options we have here. So an OR you can see is kind of a shield shape. Looks like a shield, at least to me. And we have AND, which is much more rounded on the bottom. We have an inverter. And these are probably the things that you've worked with if statements. If a clause is this, or it's this. If a clause is this, and it's this. Or not the clause that I have written down, the exclamation point in C++, for example. These other ones you probably haven't played around with quite as much. You may have played with exclusive OR if you've worked with some bitwise functions in assembly. If you watch my assembly videos, you will have seen that used for sure. That's a little shortcut on the x86 chipset for clearing out your registers. Then there is NAND, and we also have NOR. So just looking at the symbols to start out with, you can see there's definitely a pattern. Everything that has a little shield shape somehow relates to OR. If it's rounded on the bottom, I guess certain shields might look like that as well. But anyway, if it's rounded on the bottom, it's relating to AND somehow. If there's a little circle here, it is not. And in the case of this one, there's a line on top that means exclusive OR. But what does that actually mean? So let's start going through and playing around with this. So we're going to add some positive 5 voltage sources. We also will need a resistor and a ground. Let's add an oscilloscope to this resistor so we can track what it's doing. And let's start with the OR. So if I start running the simulator, you can see there is no power going across this resistor. But if I add power to either of these pins, all of a sudden we have power coming out. And that's what you would expect for an OR statement. So that's what you would expect for an OR gate. If this pin or this pin have power, give me power out. And I'm sure you can imagine what an AND will do, but let's see. If you apply no power, nothing comes out. If you apply power to one pin or the other pin, nothing comes out. But if you apply power to both pins, you have an output. Again, fairly straightforward. Now this is the one that confused me the first time I interacted with it. Because where is this power coming from? You can see that I'm not applying anything to the pin. If I apply something, it shuts off. So it's like a knot in programming. But where is this power coming from? Well, this symbol specifically here doesn't show you. Sometimes symbols will have little lines coming off of them that are kind of like this, and it shows that power is coming in and going out, and that there's an external power supply, and that is the secret of how these work. Is when you get a chip that has one of these, really all of these different gates on a chip will have a power source, and it will have a ground, a chip ground for applying or supplying external power. So again, looking at this one, right now there is 5 volts coming out, and if I apply 5 volts, all of a sudden it will drop. Now if I go into the settings here, you can see that 5 volts is the logical high that it has, and we could change this to 10 or 9 or 3.3 or whatever for the simulator here, depending on what voltages you're actually expecting to work with if you were making a chip per se. All right, so that's the NOT. Now we get into, let's do the NOR gate next. So this is just like OR, except it has an inverter on the bottom. You can see the family resemblance here. Um, so this is the equivalent of this. If you apply power in one of the pins, normally you would have an output, or the other pin, or both pins. You'd have an output, and then you're flipping it, so you're getting the inverse of an OR. If that makes sense. Hopefully it does. Now, I'm sure you can imagine. Well, let's finish this. Let's just show that all these little guys do what we expect, and they do. Let's look at the NAND gate next. And now, again, there's power. Normally, this would not trigger an AND gate. So a NAND gate, it is triggered and ready to go. However, this is what you would do to stop it from running. Pretty straightforward. Let's look at exclusive OR. This will be the last gate we'll look at today. And you may have worked with this with bitwise functions. So just like an OR gate, if this one's turned on, you have power. If this one has power on this pin, again, power comes out. Unlike an OR gate, it does not have power if both pins have voltage on them. And obviously this is useful because it is exclusively an OR gate, not an OR and an AND, which is a normal one, basically. One pin or the other, not both. And that is it. That is all that I have for you today. I hope you found this educational and enjoyable, and we look forward to seeing you in future videos. Now that we have explained these components, what we're going to do is start building things out of them, and that should be fun now that we got the basics out of the way. So look forward to seeing you in those future videos.